We're going to cover Precalculus section 4445 and 47, graphs of sine, cosine, and tangent, their inverses, and their reciprocals. So let's jump right into the sine graph. So first of all, let me draw a unit circle here. Let's see if we can get here. So hopefully we remember. Let me change my pen here. Hopefully remember sine theta equals y over r, which is opposite over hypotenuse. So, wherever our angle is, and I'm just going to draw one in the first quadrant, we have our theta, which is drawn back to, from our, we're drawing that back to the positive x-axis, and here's our right triangle. So from theta's perspective, our y value of our point is always the opposite leg, and our x value is always the adjacent leg, which doesn't affect us in sine, and the radius is always the hypotenuse. So as we look at some of these values here, and I know that if we're just using a unit circle with a radius of 1, well, to be at this point at 0 degrees, which is also 360, the point is going to be 1, 0. So the x value is going to be 1. But for sine, our important value is going to be y. So y is 0, the radius is 1. So when I'm at the sine of 0 degrees, and I'm going to start plotting these points here. Here is 0 degrees, that's 0. We'll call this pi and this 2 pi. And 360, which is 2 pi, is also going to be 0. When I go through and do negative pi and negative 2 pi, I know negative 2 pi is going to be the same as 360, so it will be our values there. Let's go to a couple of the values that we have here. Let me change my marker again. So at 90 degrees, I know I'm going to be at 0, 1. And so x is 0, but y is 1. Well, what does that mean? Well, if y is 1 and the radius is 1 when I'm at that point, so at 90 degrees, I'm going to be at 1, which 90 degrees is also going to be negative 270, which will be negative 3 pi over 2, which will be right there. Okay, let's come over to 180 degrees, which is pi, and we know that's going to be, x will be negative 1, y will be 0. So again, the x does not affect sine, but y is 0. So at pi, sine is going to be 0, and I also know this is going to be negative pi, negative 180. So if you look, I found a bunch of zeros there from negative 2 pi to 2 pi. All right, let's look at 270 degrees, which we know is going to be 0, negative 1. Again, 270 degrees, which is going to be 3 pi over 2. And I see that y is negative 1. So that's going to affect our sine value. So it's going to be, the radius is always going to be 1. So 3 pi over 2 is going to have a sine of negative 1. Well, 270 is also the same as negative 90 degrees, which is negative pi over 2, which will be right here. So hopefully, we've been working with this graph a little bit. We can start to see what our sinusoid is going to look like. And this is a periodic function with a period of 2 pi. So it's going to start here. And again, this goes on and on forever. We're only looking at it from negative 2 pi to 2 pi. And here is our graph of y equals sine x. Okay, now we're going to look at the inverse sine graph. Y equals inverse sine. This is also known as arcsine. And what we want to do, and I'm going to bounce back to the other graph for a second, we're going to restrict the domain of y equals sine x between negative pi over 2 to pi over 2, negative 90 to 90. And that's going to then give us a domain in the inverse sine graph from negative 1 to 1, because the range from here was negative 1 to 1. And it's going to give us a range from negative pi over 2 to pi over 2. Why do we do that? Well, in order to have an inverse function, I have to restrict this. The periodic function, let's go back and look. Y equals sine x is periodic, goes on and on forever, and this fails the horizontal line test. But if I put a restriction on here from right here, negative pi over 2 to pi over 2, this is one-to-one function. So this will work as we, and I should have labeled these as positive 1 and negative 1. So it reaches the height of positive 1 and the bottom of the wave is negative 1. So let's look at what our graph's going to be. So this point right here was an x value of negative pi over 2 and a y value of negative 1. Well, in any inverse, we switch that around. So now let me go through. This is going to be negative 1 and positive 1. This will be pi over 2 and negative pi over 2. So let me get that. And here is negative pi over 2. So we just said that the inverse, let's go back here, this was negative pi over 2 and negative 1. So we're going to switch that around. We're going to have a point that's negative 1, go to the left, negative 1, and down, and I need to switch my marker here, and down negative pi over 2. So there's our first point. Let's come back. This point right here is 0, 0. So when I switch my x and y for an inverse, I'm still going to get 0, 0. And there's 0, 0. And I can go back in and be a little more specific with some of the other points. And this point right here is x is positive pi over 2, y is 1, and now I'm going to switch my x and y, and so I'm going to get positive 1 and positive pi over 2. And that's not a straight line. I did not do a good job drawing that. As this slowly starts to approach and then gets a little steeper, it'd be the other way as I switch that around. Let me see if I can do a better job of that. It's going to increase quicker. That's probably a better graph for the inverse of sine of x.